Okay, here we are on page 14 where we're going to do 3D shapes. Really, we're going to focus on prisms, pyramids, cylinders and cones, and then spheres. So let's review what a prism is. So looking at number one, like if we had a pentagonal prism, then this is really, let's do it like this. There we go. Um, There we go. This is what a prism is. It's really just a pentagon on the top and the bottom and then connected by rectangles. So it gives us a few formulas that we're going to review right here. How to do a prism. So a prism, when we do it, finding the area of the base, of course, that's going to be a regular polygon like we've done in the past, breaking it up into triangles and central angles and stuff. As far as some things, there's surface area on the side. So lateral surface area, this is the area around on these rectangles. And notice they are just rectangles. So that's exactly what you're going to do. You're going to take the side length times the height. So if this is the side length and this is the height, and then the number of sides. And so some of them you'll picture n times s. That's the perimeter around the bottom times the height. And yeah, that gives you the area on the side. So perimeter times height, or number of sides times side length times height, same thing. The surface area, you're then going to add the base down here and add the base up there. So it's going to be that LSA plus 2 bases. So the area of the base. And then the volume is going to be the area of the base and times it through the height, and you'll get that. So let's do that starting with number one. A pentagonal prism, the height is 7 kilometers, h equals 7, and the side length is 3. Okay, so we got 3 here and 7 here. So that's going to, the area of the base, maybe I should call that a B, but the area of the base, let's go ahead and do that. I've got to draw a pentagon here, and this is the hardest one to do out of all of them. So we got 72 degrees in here, 360 divided by 5, cut it in half, and we get 36 degrees, and we have that the side length is 3, so this is a 1.5. So if we're going to get this apothem right here, we're going to do tangent of 36 degrees equals 1.5 over A. To solve for A, we're going to have A equals 1.5 divided by the tangent of 36. Let's plug that into the calculator. 1.5 divided by the tangent of 36. And that gives us 2.06. So the apothem is 2.06. And if that's 2.06, then we can get the area of the triangle. So the area of the base right here is going to be 1/2 the apothem, 2.06, times the 3, the side length, and then times 5, because there are 5 triangles. So here's the area of one triangle, and then we times it by 5. And yeah, you'll notice that that's the perimeter as well. So let's plug that into our calculator. 2.06 times 0.5 times 3 times 5. And when we stick that in, we get 15.48. 15.48. All right, let's get the rest of them. 3 times 7 height, so that's going to give us right here, it's going to give us 21 times 5. The lateral surface area is going to be 105. So this is kilometers squared, and that's area kilometers squared. So the surface area, let's just make sure we did that right. So the lateral surface area was 3 times 7. Let's put that like this. That's not a decimal. 3 times 7 was 21, and then we had 5 of them. This is a pentagon going around the side, so we have 5 rectangles. And yeah, 3 times 7 times 5 was 105. Now, we're going to take that. Let me double check. 3 times 7 times 5 gives 105. So that's the lateral surface area. The surface area means we just take that plus 2 times the base. So we're now going to add in this 15.484. 15.484 twice, and we get 135.97. 135.97. That's kilometers squared. And then the volume. Volume is going to be the area of that base, which is 15.48. And we're going to times it by the height, 7. 15.48 times by 7. 108.4. 108.4. And this is now kilometers cubed. We now have a volume that we're dealing with now. Good. There's number 1. With number 2, this is an octagonal prism. And so we're going to do kind of the same thing. We could do this. I'll draw a piece of it over here. Yeah. Oh, boy. There we go. Something like that. And then you have these rectangles headed down all over the place. And I'm not going to draw all of it. I think I won't be able to do it too well. And so we have a 4 by 11. So let's go ahead and get the lateral surface area really quick. That's going to be the lateral surface area is going to be 4 times 11 gives us one side times 8 of them. So let's punch that in. 4 times 11 times 8. And we end up with 352. So that's 352 inches squared. Okay, let's find the area of the base. We get, oh, this is an octagon. Yeah, we're going to have to look at this guy right here. So 360 divided by 8 is 45. Divided by 2, this is a 22.5 in here. Here's our apothem, and our side length is 4. So this means we have a 2 and a 2. So we get tangent of 22.5 equals a 2 over a. So if we're going to solve that for a, we've got a equals 2 divided by tangent of 22.5 degrees. Let's plug that into the calculator. 2 divided by tangent of 22.5 degrees. And that gives us 4.83. So that's the apothem, 4.83. So if we take 0.5 of that answer, we better put a times in there, times that answer, that gives us 1/2 times that times the base, which is 4. So 0.5 times 4.828 times 4, that gives us the area of one triangle, times 8 of those triangles. This is the area of the base, 77.25. Let's go ahead and put that in, 77.25, and this again will be inches squared. Now the whole surface area, let's write that over here too, 77.25. So if we want the whole surface area, we're going to take the lateral surface area, that's the area on the sides, and plus 2 of the bases, which is 77.25. So let's plug that in the calculator. We've got this, 2 of those, and then we're going to add it to that lateral surface area, which was 352. 506.5. 506.5 inches squared. Now the volume. The volume is going to be the area of that base times the height. Sometimes we'll use a b there. Area of the base times the height. And so we take this 77.25 and we'll times it by 11. So 77.25 times 11. And that's 849.8. That'll be fine. 849.8. Now notice here this is inches cubed. We're in a volume now. So this is what you would worry about if you were trying to fill up this octagonal prism all the way to the top, like a cup, filling it up with water. Whereas the surface area is if you were going to paint all of it, including the top and the bottom, like a can. The lateral surface area is if it were like a pipe with no top and bottom. And then, of course, the area of the base is just the top and or the bottom. All right, let's move on to the next one. Number 3, this is a triangle prism. So I'm going to draw that guy up here so we can kind of see what we've got going on. So here's a triangular prism. And we're sitting up on this edge, so we have the area of the base down here. And let's go ahead and draw this guy as well. All right, so we have the height and the side length. So the height is 10 and the side length is 8. So if we just look at the bottom here, We have side length 8. And yeah, let's go ahead and split that up. Now this one, it says to do exact. So we better keep this exact. That's 120 degrees. So when we split it in half, we get a 60. And this is a 4. Oh boy, 4, we have to divide by the square root of 3 to get to there. So this little apothem here is 4 divided by the square root of 3. We don't leave square roots on the bottom, so we're going to times top and bottom by a number that will allow that to be 4 square roots of 3 over 3. And then this guy is going to be 8 square roots of 3 over 3, but I don't think we need him. So the area of the base is going to be 1/2 times the apothem, 4 square roots of 3 over 3, times the side length, which is times 8, and we have 3 of them. All right, so what do we get here? 1/2 times, let me see, this 3 and that 3 will cancel. That 4 and that 2 will cancel, leaving a 2, so we get 16 square roots of 3. So that's the area of the base there. Now, the lateral surface area is going to be, LSA is going to be 10, that's the height, times the side length, times the number of sides we have, which is 3. So 10 times 8 times 3. So 10 times 8 is going to get you this front face, and then there are 3 of them around there. So 80 times 3 is 240. It's going to be 240. Now notice that these are areas, so these are yards squareds. And so the whole surface area is 240 plus 2 of these, so plus 32 square roots of 3, and that's all yards squared. Okay, and the volume. We're going to take the area of the base times the height, so we're going to get 16 square roots of 3 times the height is 10, so 160 square roots of 3. At first, the exact requirement is a little bit tough, but you can see we didn't need a calculator for all of these. That was pretty cool. All right, number 4. Number 4 is a nonagonal prism. So I don't even know how to draw that guy, but I'm going to do it like this so you can kind of see what we've got going on, and then we'll have one down there. And so these rectangles going around. So let's first find the lateral surface area. That's going to be the easiest one. The side length is 12. Oh, these are fat little rectangles. So the lateral surface area, we're going to have 12 times 5. Oops, 12 times 5. And then we've got 9 of those rectangles. So 12 times 5 and then 9 of them. And that gives us 540. So the lateral surface area is going to be 540 centimeters squared. Okay. Now we got to find the area of the base. So this is, again, I'm not going to draw all of them. I don't even know what a nonagon is going to look like, but I do know that when we draw that out, we have a little rectangle here. Here's the apothem that we need in order to find the area there. 360 divided by 9 is 40, so we're going to have an angle of 20 right there. And this is the right angle right here. And what do we have? The side length is 12, so this is going to be a little 6. So we get tangent of 20 equals 6 over A. So A equals 6 over the tangent of 20. And so we get, plug that in the calculator, 6 divided by the tangent of 20. And that is 16.484. That's the apothem here. So the base is going to be 1/2 times the apothem, 16.48, times the side length, which is 12, and that'll give us the area of one triangle times 9. And again, look at how we're using the perimeter all the time in these computations, getting the perimeter and timesing it by the height, or getting the perimeter and doing 1/2 times the apothem. We'll get the area inside. So it actually comes up quite a bit, that perimeter. All right, let's go ahead and multiply this out on the calculator. We have that times 1/2 times 12 times 9, and it's 890.2. So I'm going to write that down, 890.2 centimeters squared. All right, surface area, we're going to take 2 of these plus the lateral surface area. So times that by 2 plus the 540, and that'll give us the total surface area, which is 2320.4. 2320.4 centimeters squared. Now onto the volume. So really, with volume, you're taking the area of the base and you're timesing it through the height. So you fill up the entire container. And so the area of the base was 890.18. 27. We got a few decimals there. And times it through by the height, which is 5. And we get 4450.91. 4450.9. 4450.9. This is centimeters cubed. Little note here, they also abbreviate centimeters cubed as cubic centimeter, cc's. That's the same thing that's in the medical field. Cubic centimeters is a milliliter because 1,000 cubic centimeters makes 1 liter. Or it's also in the automotive profession, size of engine. So 4450, that's a very large engine. If you get like a 250cc engine, that's pretty big. But anyway, so that's kind of a cool connection. All right, number 5. Wow, if I thought 9 sides was going to be tough to draw, 18 sides is certainly tough to draw. So I'm just going to draw a few of them here so we can kind of see what's going on. Yeah, so here's our prism, and we're going to have 18 of these little faces going around here. Uh-oh, we don't have the height. Oh, we're going to have to do some backwards fun stuff here. We do have the volume is 800 meters cubed. So we're going to keep that up here. Volume is 800 meters cubed. And we know the side length is 3. So let's see if we can go backwards from that. Side length is 3. I think we can get the area of the base. So let's try this. The area of the base is going to be, we need to find that apothem first of all. Let's draw a little triangle out here that represents what's going on. So we've got 18 sides. Central angle, that's 360 divided by 18 is 20. That means we've got a little 10-degree angle here, the apothem, and that's going to be a 1.5. That's half of the side length. So we're looking down at the top of that 18-sided figure there. And we get tangent of 10 degrees is 1.5 divided by the apothem. So A equals 1.5 over the tangent of 10. And in the calculator, we get 1.5 divided by the tangent of 10 degrees, and that's 8.5. Almost dead on. So the apothem is 8.5, so the area of the base is going to be 1/2 times this 8.5 times the side length, which is 3. So that's 1/2, 8.5 times 3. That'll give us one triangle. Let's draw that down. That'll give us that one triangle times 18. So let's go ahead and punch that all in. That times 1/2 times 3 times 18. Enter, and we get 229.68. So the base, the area, is 229.69. 229.69, and that's going to be meters squared. Okay? What can we do from that now? Oh, since the volume equals base times the height, and we know the area of the base, we can divide that and get the height. So it's going to be 800 over that 229.69. So let's get the height now. So 800 divided by that answer gives us 3.48. So the height is 3.48 meters. All right, okay, good. So now we can use this to get the lateral surface area, because if the height is 3.48 and the side length is 3, we can find the area of this side. So the LSA, we're going to have the height, which is 3.48, times the side length, which is 3. That'll give us the area of one rectangle, times 18. So let's go ahead and punch that in. 3.48 times by 3 times by 18, and we get 188.1. So lateral surface area is 188.1. And again, that's meters squared. All right, so now to get the whole surface area, we're going to take that plus 2 times the base, because we have a base on the top and a base on the bottom if we want to find all the area on the outside. So that's plus 2 times our base area was 229.69. And that gives us 647.5. 647.5, and that's in meters squared. Oh, look, we did that going backwards. Okay, moving on to cones. Okay, moving on to pyramids. Now, in pyramids, let's look and see what's going on here. We're going to have a polygon down here at the bottom, and it could have so many sides, I don't know, but it comes up, instead of being straight up with rectangles, it comes up to a point, which means that these are all triangles around here. And they have, instead of the height coming down here, they have a height that we're going to measure to get the area on that's a slant height. It has an L. So let's look at them and see if we can write up what has pyramids. So with pyramids, there are certain formulas we can make here. And you can look these up if you want, but it's going to be the same thing. So notice what happens here. The lateral surface height, just the lateral surface area on the sides is made up of a bunch of triangles. So we're going to have n times the area of these triangles, which is 1/2 the side length, but then we don't use the height. Each one of these triangles is going to be measured in its area based on how slant height it has. So it's called an L over there. So we're going to use that. We're going to have to find it, and you'll see that HA and this slant height form a right triangle. So we may use Pythagorean theorem a couple of times, but notice here's the perimeter again, and so that'll come into play. The surface area is going to be the lateral surface area, but notice that we only have one base that we can add to it. So the stuff all on the sides are all these triangles, and then the base, which is a bunch of triangles as well when we find the area of the base. And then the volume, and this is a very interesting relationship. We're going to take the area of the base times the height, and being a three-dimensional object, it actually requires 3 of those to fill up a prism of the exact same height and base. So it's 1/3 of the base times the height. So you take the base times the height, and then you have to divide it by 3. Okay, so that should help us as we try to navigate these pyramids. So let's do it. Heptagon. So this is something that has 7 sides. So assuming we have 7 sides, let's use this picture up here and see if we can get it. So the height is going to be 7, and the side length is going to be a 5. All right, so we're going to have to chop up the area of the base here. So I don't know what a heptagon really looks like, but we're going to do it like this. So we've got to take 360 divided by 7 and then cut it in half. So let's do that. 360 divided by 7 and then cut it in half again. There we go. So 25.71. That's what this angle here is, 25.71. Here's the apothem, and the side length is a 5. That means we have a 2.5 here. So the tangent of 25.71 equals 2.5 over A. A equals 2.5 over the tangent of 25.71. So 2.5 divided by the tangent of 25.71, what does that equal? Ooh, the apothem is 5.19. That's going to be good. So we've got 7 of these triangles. Let's figure out the area of the base. It's going to be 1/2 times the 5.19 times the side length, 2.5. That gives us one triangle times 7. And that equals times 0.5 times, oh, I messed up there. The side length isn't 2.5. That was just half of it. It was a 5. So 1/2 times 5.19 times 5 times 7. And so the area of the base is 9.865. So 90.9. 90.9. That's going to be millimeters squared. All right, so now the tough thing comes. We have to use the apothem, which comes out here, which is going to be 5.19, and the height, which is 7, and make that a little right triangle to get the slant height. So we've got this little h squared plus a squared equals the slant height squared. And we use an L because S is already used up, and that's the next thing in slant. Okay, so we get 7 squared plus 5.19 squared, and then we have to square root that to get L. So we have here 7 squared plus 5.19 squared, enter, and we get square root of that 8.71. So our slant height is 8.71, and that would be millimeters. Good. So the lateral surface area now, we have 7 triangles that look like this. Let's draw them here. So if we were to cut up the pyramid into the triangles that are now going around the outside, we have this side length of 5 and this slant height down here of 8.71. So the LSA is going to be 1/2 times the height, 8.71, that's the slant height, times 5 times we have 7 sides. You'll notice it's the exact same thing we had up here, but here we were measuring the 7 triangles by their apothem, and now we're measuring by their slant height. And so let's punch that in. Times by 0.5 times 5 by, that's the slant height, times the side length, times 7. And the 1/2 was because we're in a triangle. So that gives us 152.5, LSEA, 152.5, and is millimeters squared. And then the surface area is this lateral surface area plus the base. Oh, that's nice. We can just add up on the base 90.9, and we'll get 243.4. 243.4. And again, that's in millimeters squared. And that's really all it is, the area on the side plus the area on the bottom. And now the volume. Volume is going to equal, how do we get volume? Oh, it's the area of the base times the height, but then we divide by 3 because we're a pyramid. So area of the base, which is 90.9, times the height, which was 7, and then divide by 3, and we get 212.1. This is 212.1. This is now millimeters cubed as we're doing a volume. Okay, that's pyramids. Okay, let's try number 7, being exact. A square pyramid. So here we have, we can draw this one. Well, sort of. So up here. Yeah, look at that. So like the pyramids in Egypt, something like that. And now it says to keep it all exact. And we can do that because every time we cut up a square, we get 45, 45, 90 triangles, and so we can keep it all exact. So we also have to work backwards. It gives us the volume of 270. So volume's 270 yards cubed. And it gives us the height is 10. So working backwards, we have to find the area of the base. So the volume is the area of the base times the height, all divided by 3. That's important. So this is 270. So we're going to times by 3. So we get 810 equals the base times the height, which is 10. Divide by that, and the base is 81. Oh, that's too easy. We now have a square, and the area is 81. Oh, that means we're at a 9 by 9. That was way too easy. The side length is 9 yards, and the area of the base is 81 yards squared. That was too easy, too easy. However, we're going to get a little bit tougher now. So we still need to find, if we can draw this in here, we still need to find the apothem here and the slant height in order to get the lateral surface area. So this is a right triangle where we have h squared plus a squared equals the slant height squared. You know, we really should write that down as something that will always happen. H squared plus a squared will always be the slant height squared. All right, now back to it. So in a 9 by 9, if we do this right here, we know that that guy is 4.5. He's halfway to the 9. So this is 10 squared plus 4.5 squared, or we should have 9 halves squared if we're going to keep it exact, equals L squared. Okay, so this is 100 plus 81 fourths equals L squared. Add those two together, and this is the same as 400 fourths. This is 481 fourths equals L squared. So L is going to be 481, the square root of it, over square root of 4 is 2. Oh boy, that's L. Wanted to keep it exact. That's funny. Square root of 481 over 2. That's kind of hard to read. Square root of 481 over 2. And that's going to be in yards. Okay, so the lateral surface area, LSA, is going to be 1/2 slant height, square root of 481 all over 2, times the side length, which is 9, times by 9. 1/2 times the lateral surface area times the side length times the number of faces. So this gives us one of these triangles. So we just did 1/2 this times this. So that gave us one of them. And now we're going to have times 4 sides. Well, that 4 cancels with that and that. So we get 9 square roots of 481. Didn't come out really nice, but that's true. So the surface area is then this one, 9 square roots of 481, plus the area of the base, which is 81. And we only have one base. We don't have a top and a bottom. So these are both in yards squared. Yards squared. Okay, that was kind of interesting. Let's move on to number 8. All right, we have a decagonal prism. No, decagonal pyramid here. So we've got, I don't know, somehow 10 sides coming around here like this, and they all come up to a point. There we go. So we've got height coming down in the middle here of 12. And then this coming over here, we've got to find the apothem, so we can find that. So let's look at the bottom straight on. So we have, I don't know, 10 sides that look kind of like this. And 360 divided by 10 is 36. Cut in half, this is 18 degrees. And the side length is 15. So this is going to be a 7.5 right there if we've got 15 along the whole side. And this is A. Tangent of 18 equals 7.5 over A. Solve for A, we get A equals 7.5 over the tangent of 18. Punch that in. We're getting a little bit quicker at these. 7.5 divided by the tangent of 18 equals, wow, 23.1 is the apothem. So to get the area of the base, we're going to take 1/2 times the apothem, 23.1, times the side length, which is 15, times the number of sides, which is 10, those number of triangles that we have in the base, like this. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So let's punch that into the calculator, and we get that times 0.5 times 15 times 10. There we go. And that is 1731.2, 1731.2. And that's going to be in meters on this, in this one. So that's the area of the base. Now we've got to find the slant height so we can get the area of the triangles on the side. So we have 23.1 squared plus the height squared equals this slant height squared. So we're going to square root both sides, and let's plug that in the calculator. 23.1 squared plus 12 squared, and then square root that guy. Good. What does he come out to be? 26.03. So this slant height right up here, 26.03, and that's going to be 26.03. This is just a length, so this is in meters. All right, the lateral surface area is going to be 1/2 of the 26.03 times the side length, which is 15, 10. You'll notice these are just 10 different sized triangles going around as they're headed up as opposed to flat on the ground. So let's punch these in. 0.5 times 26.03. Oh, I could have just used that answer right there. Yeah, let's insert answer. There we go. Times 15 times 10. Good. And we get 1952.32. 1952.3 is in meters squared. Oh, that's a meter squared on that area before. So when we take the surface area on the side plus the bottom, that will give us the whole surface area. So add that to the 1731.2. And that gives us 3683.5. 3683.5 meters squared. Good. And now the volume, the last one, is that area of the base, which is 1731.2, times the height, which is 12, all divided by 3. And let's punch that in. So we have 1731.2 times 12, and then we divide by 3. And that gives us 6924.8. 6924.8 meters cubed. Now you'll notice sometimes I'll be carrying 1 decimal and 2 decimals. As we early on round our numbers, I've tried to keep them in the calculator as much as I can, but you may experience some rounding error if you round one time and use that rounded number later on. So these numbers might be off by plus or minus 0.2. Happens in chemistry and physics classes all the time, but the discussion of significant digits and where we're rounding are beyond this scope of what we're doing now. So just go ahead and round at 1 or 2 decimal places and it'll be fine. All right, last one. Ooh, a hexagonal pyramid, and we've got to get it exact. Ooh, that might be a little bit tough, but we can do it. Okay, so I'm going to try to draw it the best I can here. There we go. Okay, so on the bottom we have a hexagon. So side length is 4 and the height is going to be 5. Let's keep that in mind. The apothem over here, we can get that. So let's draw the base so we can see it. So we have side length 4. And we're going to cut that down there. That's a 30, 60, 90 triangle. So yeah, if that's a 2, that's a 4. And the apothem is 2 square roots of 3 because it's a 30-degree triangle. So the apothem is 2 square roots of 3. The area of the whole base is going to be 1/2 2 square roots of 3 times the side length, which is 4. So we did 1/2 apothem times that side length to get one triangle times 6. You'll notice that 2 cancels there, and we get 24 square roots of 3 for the area of the base. Okay. Now with that apothem, we've got 2 square roots of 3 squared plus the height, which is 5 squared, equals that squared. So we're going to square root it to get the slant height. We have 4 times 3 is 12 plus 25. That's 37 and square rooted. So that's L. We got this by squaring 2 and squaring square root of 3, which is 3. 4 times 3 is 12. So the square root of 37 is the slant height. So the lateral surface area is going to be 1/2 times this slant height, square root of 37, times the side length, which is 4, times the number of triangles, 6. So we're finding the area of this triangle right here, and then we've got 6 of them going around the side. So you'll see it's the same thing we did for the area of the base, but now that triangle is tipped up at this height instead of the apothem being the height of the triangle. So this is, that'll be a 2, so 12 square roots of 37. 12 square roots of 37. So the surface area is this plus that. Well, those are not like numbers. 12 square roots of 37 plus 24 square roots of 3. I don't even know what that looks like as a decimal, but there's the exact version of it. So in the slant height, we should put that in square root of 37. And we should label all these. That's feet. Area is going to be in feet squared. Area is in feet squared. And area is in feet squared. Okay, and the volume. The volume is going to be the base times the height, all divided by 3 because we're in a pyramid. So the area of the base, which is 24 square roots of 3, times the height, which is 5, all divided by 3. So the 24 and the 3 cancel and get an 8, so we get 40 square roots of 3. And that is in feet cubed, cubic feet for volume. Okay, that's pyramids.